Hello everyone. In this short video, I am going to explain in a bit more detail the area of sampling versus ray bounces under the Arnold renderer that we talked about in class. It seems like some of you were a bit confused as to how those two things relate and how they relate to the overall render of your model. So hopefully this will clarify things just a bit. So let me introduce the room that we're working with. In the room scene that we have a room that I created with a cube, and I reversed the normals in that cube so that I could get the room lit from inside whenever I apply lights to it. I also introduced into this room that small model that I gave you at the beginning of the semester with the red wagon, and I've also applied 3 lights to this scene. 2 of them are area lights. Sorry. 2 of them are area lights, and the other one is a sky dome. Now notice that the area lights have a value of about 7,000 each in intensity. So if you look at the intensity, it's about 7,000. And if you look at the sky dome has a value of 2 on intensity. So those are the setup. Now, the reason how I got to those values is by looking at the size of my room. Keep in mind that area lights are quadratic lights. That is, that they act like real world lights and their decay is quadratic. And so whenever you're lighting an area with area lights, whenever you're lighting a volume area with area lights, or any quadratic lights for that matter, you need to take into account the size of the actual environment, because light will travel and start to dissipate and disappear the further away it gets from the light source. So let me take a look at the room, and what I did in this room, let me go to the channels box and go ahead and take a look at the original poly count for the cube. You'll notice that we have a value of 152 all around for this room. 152 centimeters equals roughly about 5 feet. So this is a fairly small room. And with that in mind, then it told me we worked with a room that was 10 by 10 by 10 during the class sample that we were working on, and we were using values up to 15,000. So I figured with a room half the size, then I need a light intensity that's about half the amount that we use in class, and that gave me those values of 7,000 for the area lights. And then we have the sky dome to create a general hue of light all around, and that's the one that I only applied a value of 2 in intensity, and 2 is more than plenty for that sky dome for a room this size. So with that said, let me go ahead and do a quick render. Let me open up the Arnold renderer and make sure that I am at 50% so that this renders fairly fast. And let me go ahead and run an IPR. So now let me go ahead and select my perspective viewport. By the way, you can also change that up here. So if I select perspective shape, that is my perspective viewport. And as you can see, I am getting a grainy render. Not the best, but it's visible. At least I can see on this sample render what lights are doing inside my room. Not the best of renders, and as you can see, it still takes quite a long time to render. So now the idea is for us to go ahead and play around with the sampling to be able to increase the quality of our renders fairly quick, and to take advantage, understanding what each one of those components within the sampling does, what we can turn off, what we can turn on, and where we can increase the values. So to do that, let me go ahead and open up the render settings window by clicking under by clicking under the clapboard that has the little gear next to it. And that opens up my render settings. I am going to launch this to the right hand side of my Arnold renderer so that I have both of them together. And let me go ahead and start talking about how things relate to each other. So the things we talked about in class that relate to each other are the sampling area, the rate depth, and the environment. So let's talk about first sampling. Increasing the amount of samples is quadratic, as I explained in class. Basically, if you look at the values for each one of these components, you're talking about anti-aliasing when you're talking about the camera. that refers to those little grains that you see on the wall on the highlights, basically the noise in the overall texture of the file. That's what this is talking about. So increasing that value reduces the amount of grain that you see on your renders. Diffuse refers to what we call color, and that is basically the light that is bouncing off the objects, of the shaders, towards the camera, and the amount of light that is being captured within those bounces. So if we increase diffuse, we're going to get a bit more light going into the scene based on the amount of colors that we have within that scene. Specular, as we know, refers to the highlights. So this refers to the areas where the light is increasing in intensity within the scene. So bounces on the floor, light bouncing off the wall, this highlight on the red wagon. These are all things that will be influenced by increasing the value of a specular. Again, it will increase not just the quality, but the amount of light that is being captured. Transmission refers to how light goes through the materials. So since we don't have anything in this scene that is transparent or that has any value of refraction applied to it because no light is going through it, I can go ahead and turn off the value for that completely to increase the amount of CPU power that is allocated to the other components. Subsurface scattering, as I explained in class, refers to the light going through an object and how it's dispersed through that material. So things like skin, wax, marble, those are the things that are affected by subsurface scattering. Since I don't have anything like that in this scene, I'm also going to turn that off. And volume refers to the overall lighting when we applied volumetric lighting to the scene. So if we have something that is kind of like the particles that we see in the air, like I explained in class, water, dust, any materials that are in the air that influence the way that light is refracted or reflected, that's what is influenced by that value. I will keep that value as is for now. So these are the values that affect the sampling portion of the render. These values, these components work in direct relation to the rate depth values. Now, rate depth is exclusively talking about the amount of light bounces within the scene for any photons coming from the light source. So if based on the values of light that you see originally with the default values, any increase on any of these components will increase the amount of light bounces that are within that particular component within the scene. And what that means for you is basically it will increase your render time significantly. So any little value change on this will increase your time significantly. But you can actually control that by looking at the numbers that are up here under the sampling. So these numbers relate directly to how these numbers are calculated and the amount of rate bounces that you have in here. If you look at the minimum value here, it's basically the value that you see in this component box squared. So for camera AA, which is anti-aliasing, the grain, we have a value of 9 right now. And you can see that that's what shows up there. Okay. If you look at the diffuse samples, that's this component here. That is this square times this square. So that would be 2 times 2, it's 4. 3 times 3 is 9. 9 times 4 is 36. And that's the amount of the samples that are being used for color calculation. Now, the maximum number is this value, whatever this value. Actually, let me pull up this formula so you guys have it in front of you. So you have a maximum component samples is equal to the minimum amount of samples plus the AA samples, the first value up at the top of the samples, times the diffuse rate depth minus 1, or the component rate depth minus 1. So in this case, we're doing the calculation for diffuse. Therefore, that's what you see. But if instead of diffuse, you were calculating transmission or you were calculating any of the other components, basically it's the same formula for all of them. Now, you don't have to worry about the numbers themselves. What really matters to you is that you maintain these numbers within a normal amount, meaning do not go here and increase this to 5,000 or something because you're going to break your computer. Go one by one and take a look at the rendering quality as you increase. That said, one thing to keep in mind is that under rate depth, the total amount of rays that is listed here, in this case 10, the total amount of rays is the calculation of all these values put together. So in this case, we have 1 plus 1 is 2, plus 8 is 10, plus 10 is 20. This is only calculating half of the amount of values that I had told it to bounce, the amount of light. And the reason for that is because the more I increase the amount of rate depth, the longer my rendering time is going to be. So let me go ahead and with the base values that I have, let me go ahead and do a screen cap of this. So as you notice, I just clicked on that little icon at the bottom of my rendering window, and that captured a snapshot of what I'm looking at. Then let me do a couple of things. Let me first increase the value of my anti-aliasing from 3 to 6. I am going to double it. And let me go ahead and increase my diffuse sampling to 4. Let me increase my specular to 4 as well. So I'm basically doubling all these values under the sampling. Just changing the sampling for now, and I am going to wait out how this is going to render. Let me pause for just a second and I'll be right back. As you can see, this took about 4 minutes and 34 seconds to render by having that setup that we have, that we double the amount of values just for the anti-aliasing, the diffuse, and the specular components. But as you can see, it's quite an improvement on the original setup, on the original render. So let me take a look. Let me compare the original render to the new render. You can see the anti-aliasing has significantly increased in quality, and the overall lighting is a little bit more even. However, there's not a lot of improvement on the actual light itself on the scene. And that is because we are, that's because we are not really, we haven't touched the rate depth area of our render. If you recall, this is where most people will automatically start increasing the value of their lights, increasing the intensity of their lights, and this is where things go wrong, because it's not that you don't have enough light, it's that you are not capturing enough light within the scene to be rendered within your image. So to do that, we need to go back onto the rate depth area of our render, and we need to do several things. First, I don't have any transparency values in here, so I am going to decrease that value, allocating more rendering CPU power to whichever components I am truly actually focusing on, which in our case are diffuse and specular. I also don't have any transmission value, so I'll bring that down. And what I'm going to do is I am going to increase my diffuse value to about 5, and I am going to increase my specular to about 5. Now, let me go back to my scene, and you'll notice that this is rendering automatically, and I am going to pause again and wait for that render to complete. As you can see, this render took about 7 minutes and 29 seconds. Let me do a quick snapshot of that scene and let's compare. So the first one, it's our very grainy, standard, very low. You can see the amount of samples down here. Let me compare that to the second one where we double all the samples that we're rendering, and you can see an improvement on the quality and the lighting. And then let me take a look at the third one, and you can see there's an increase on the amount of light that is being captured on the scene. Now, compare the first one to the last one. You can see there's quite a lot of quality and improvement. And like I said, this only took about 7 minutes and 30 seconds to render. So that gives you a rough idea of how long your scenes will take to render based on how you increase the values for whatever components you are controlling from within the sampling and the rate depth. To this, you can also add an environment atmosphere, and that will definitely increase the rendering time, but will also increase the amount of light that is bouncing off the air. So let me go ahead and apply an environment atmosphere map, volume map, and let's go ahead and increase the quality of that volume map to about 0.8. That would be actually a good value to work with. And let's see, let me stop here for a second and do a quick render. As you can see, this last render took about 14 minutes and 30 seconds, so about twice as long by simply increasing the values of diffuse and specular components under the ray depth. Let me do a screen cap of that. And now let's compare the first render, which was the one with the default values you see as dark and very grainy. Improving the quality on the render just on the amount of samples gave us a better quality render, but still quite dark. We went ahead and increased the amount of ray depth samples slightly and reduced the amount of turned off transparency and all those other values that we were not rendering. So we saw an increase on the quality of the lighting overall. Then I added atmosphere to this, and you can see now that the look of the overall light is a lot more natural. This is a little bit hot up here, and that's because the light is very close to that wall. So I need to move back my area lights further away from the window. As you can see from my layout, the lights are basically butt against the actual wall, against the window. So that's what's giving that intense highlight up here. So I wouldn't call this my final render. You can also see that this is getting really bright down here. So we might want to pull those lights back slightly and perhaps even reduce the intensity value for those lights. But overall, we're getting much better overall lighting on the scene. So I hope this explains in detail what we were talking about when we were talking about sampling versus rate depth, noting that this increases the quality of the overall render, and rate depth, this area here, controls the amount of light bounces that we're getting from each one of the components within this scene.